said, what was the most interesting experiment you've done?
The most interesting experiment? Remember, I'm a theoretical chemist. So what I do, that's a minority of people in chemistry. And those are people who do calculations on molecules that do not exist. And I'll tell you, rather than about an experiment, I'll tell you about a simple thing that I found out or a simple theoretical thing that I thought about. But I'm going to have to show you a model for that. So just hold on a minute while I build the model. Okay, so here is a little model made out of a metal jack and 4 green straws going from it. Does everyone see that? I'll try to hold it against my body so you can see it. If I move it around, and incidentally, part of the fun of playing with models is you get to work out your nervous tendencies on them. You can do things, you can twirl them, you can bend them, and nobody screams. Okay? So this model, what it shows is 4 things coming out from the jack. You can see very clearly that the 4 directions are not in one plane. They're going off actually toward the corners of a mathematical solid called a tetrahedron. This is the way that actually the methane molecule, CH4, looks like. Methane is the main component in natural gas. Do some of you have a gas stove at home? A kitchen in the kitchen? That's what this stuff. That's what's burned in here. There is a telephone ringing. Just ignore it, please. So this is the way that the 4 hydrogens go off in the. I gotta turn it off. Okay. That they go off in a methane molecule and in all organic molecules. They go off like this. So one day, it was a long time ago, I began to think, I know that this is the way that the bonds go off in methane. But I began to think that maybe they go off not in this way, or what would it take to make them go off into a plane? So look what I'm doing to the model. What I'm doing to the model is I'm distorting it toward a square planar one. Everyone see that? It is going off toward all the bonds going in a plane. I can't do it without breaking the model. Okay, I thought about this in a computer. I calculated how much energy it would take to distort this molecule. But I wasn't just interested in the discomfort of the molecule. I wasn't just interested in that it took 60 kilocalories to bend this molecule. You're going to learn about the units. You're going to use units like kilojoules for energy. What I was interested in was something much more interesting. That is, what can I do to this molecule in order to overcome that hill, that barrier? Now, what I can do is replace the hydrogens at the ends of these green bonds. You don't see them, but that's what the ends of these stand for. And I could put a ball, and then you think you see it, but you don't really see it because this is just a model. But what we did was we put some things out on the 4 corners of this tetrahedron, which were not hydrogen. And organic chemists can do this. And we were able to predict that for certain things that you put on, the energy would go down to distort it toward the square planar. Is this going to be a new anti-cancer drug? No. Is this going to be something I can patent? No. It's just fun to know because it gets at what is fundamental, and by uh, in what is fundamental, why this wants to be one of those geometries and not the other.